All right, let's talk about one of the most mysterious particles in the entire universe. I mean, this thing is so strange, so incredibly hard to pin down, that scientists have nicknamed it the ghost particle.
So to really wrap our heads around this, let me ask you something kind of crazy. What if I told you that right now, this very second, billions of invisible particles are passing right through you? I'm talking about particles born from stars, from the Big Bang itself, just streaming through your body, the chair you're sitting in, the whole planet, like it's not even there.
Well, here's the thing. It's not a what if. It's not science fiction. It's happening. Right now, these ghost particles are absolutely real, and they have a name, neutrinos. So, what in the world is a neutrino? You know, one of the scientists who found it, a guy named Frederick Rains, had this amazing quote. He called it the most tiny quantity of reality ever imagined. Think about that. They're fundamental building blocks of the universe, kind of like an electron, but way, way weirder. Okay, so what makes it so weird? Well, for starters, it has no electric charge. So magnets and electricity, it just doesn't care. It also has a teensy tiny bit of mass, so little in fact that for a long time we thought it had no mass at all. But the real kicker is how it interacts, or rather how it doesn't. It's ruled by something called the weak nuclear force, and let me tell you, it is weak. A neutrino could literally pass through a light year of solid lead and probably not even notice. And just to give you a sense of how many are out there, look at your thumbnail, okay? In the 1 second it took you to do that, about 65 times billion neutrinos from our sun just passed right through it, every single second. It's just staggering.
So where do they all come from? Well, pretty much anywhere there's a cosmic spectacle happening. They're leftovers from the Big Bang itself, they're pouring out of the sun's core, they get blasted across the universe when giant stars explode. Heck, we even make them right here on Earth in nuclear reactors. And they're created when cosmic rays smash into our atmosphere. They're everywhere.
Okay, but this brings up a massive problem, right? If these things can fly through a light year of lead, how in the world do you catch one? How do you even build a trap for a ghost? Well, the first step is kind of counterintuitive. You go deep, deep underground. You bury your detector under a mountain. Why? Because you need to filter out all the other cosmic noise. All those other particles flying around get stopped by kilometers of solid rock. But the neutrinos, they don't care about a little rock. They sail right on through, giving you a clean signal. Okay, step 2. You need a target. And not just any target, a gigantic one. Remember, the odds of a neutrino hitting anything are almost zero, so you have to play the numbers game. You build something huge. Take Japan's famous Super-Kamiokande experiment. They use 50,000 tons of ultra-pure water. It's basically a giant waiting room for a ghost. I mean, just try to picture that. A tank the size of a 10-story building, filled to the brim with super clean water, all sitting in a huge cave carved out a kilometer under a mountain. The scale is just mind-blowing, and all that work, is just to slightly increase the tiny, tiny chance of one of these things finally bumping into something. All right, so here's the magic moment. What happens if you get lucky? On the rarest of occasions, a neutrino will slam into a water molecule. Bam! This collision creates another particle, say an electron, that goes flying off so fast it's actually moving faster than light can travel through water. Now this creates something amazing, a kind of sonic boom but with light. It's this faint cone of blue light. And the walls of this giant tank, they're covered in over 11,000 of the most sensitive light detectors imaginable, all just waiting to see that one tiny flash. You know, someone who got to go inside the tank when it was empty for maintenance said it felt like looking through a portal into another universe. And you can see why, right? Just looking at all those thousands of golden sensors, these eyes staring back at you. It really hits home what an incredible achievement this is, all in the name of seeing the invisible.
But here's where the story gets even crazier. Building these amazing ghost traps did more than just prove neutrinos were real. It actually stumbled upon a massive puzzle, a mystery that stumped scientists for 30 years, and in the end, completely changed physics as we know it.
They called it the solar neutrino problem. Here's the deal. For decades, every single experiment that tried to count the neutrinos coming from the sun came up short. Like, way short. They were only seeing about a third of what our models of the sun predicted we should be seeing. The math was just wrong. So what was going on? Were all these incredibly expensive experiments broken? Or did we not understand our own sun?
The solution was something nobody saw coming. It was wilder than either of those options. The neutrinos weren't listening at all. They were changing their outfits in the middle of their trip.
They were performing a quick change act, a phenomenon we now call neutrino oscillation.
So it turns out neutrinos come in 3 different flavors. There's an electron neutrino, a muon neutrino, and a tau neutrino. Think of them like vanilla, chocolate, and strawberry. The sun only makes the vanilla kind, electron neutrinos, and those early detectors, they were built to only see vanilla. So what was happening was that on the 8-minute trip from the sun to us, 2/3 of the vanilla neutrinos were changing into chocolate and strawberry, making them totally invisible to our detector.
And here is the absolute bombshell. The laws of quantum mechanics are very clear on this. For a particle to be able to change flavors like that, it must have mass. It has to. And this was a huge Nobel Prize-winning deal. Why? Because the standard model of particle physics, our rulebook for the universe, had always said neutrinos were massless. This discovery was the first real crack in what we thought was a perfect theory.
Now, this whole passing through everything superpower, it makes the neutrino the ultimate cosmic messenger. Think about it. Light gets blocked, it gets scattered, it gets absorbed. But neutrinos? They fly straight out from the heart of the most insane cosmic events, carrying secrets from places that light could never escape. We saw this happen in real time back in 1987. A star exploded, a supernova, and our neutrino detectors on Earth lit up. They saw a huge burst of neutrinos. But here's the incredible part. Our telescopes didn't see the first flash of light from that explosion until 3 hours later. Why the delay? The neutrinos shot straight out of the star's collapsing core instantly, while the light had to battle its way out through all the chaos and debris. We got a 3-hour heads up, a message delivered directly from the heart of a dying star.
And believe me, this story is not over. Not by a long shot. Right now, scientists all over the world are building the next generation of these detectors. They're going to be bigger, way more sensitive, and they're designed to tackle some of the biggest, most fundamental questions we have about the universe.
For example, the follow-up to Super K is called, you guessed it, Hyper-Kamiokande. It's going to be more than 5 times bigger. We're talking 260,000 tons of water. At the same time in the US, they're building the Deep Underground Neutrino Experiment, or DUNE. These aren't just small labs. These are massive, global projects on a scale that's hard to even comprehend.
And what are they hoping to find with these new behemoths? Well, just the biggest questions you can think of, like why is there more matter than antimatter in the universe? In other words, why do we exist at all? They want to finally nail down the exact mass of each neutrino flavor. They're even going to check if protons, the building blocks of you and me, might eventually decay. These are the big ones.
Which leaves us with this one final mind-bending thought. Could it be that this tiny, nearly weightless ghost particle, this elusive messenger that's streaming through you right now, could it really hold the key to our own existence? It's just incredible to think that the answer to the biggest question of all, why are we here, might be hiding in the smallest thing we've ever imagined.